And there's the disconnected transformer board. The whole system was drawing about 185 watts with this connected, and there's of course going to be about 90 watts power dissipation in the lamps, because these are 75 volt lamps, but they're operating on 67 to 68 volts, so their actual operating power will be about 45 watts or so. Then of course about quarter watt for the little tiny idiot light there, because it's only running on 1.9 volts, and that means that there's probably about 20 watts of, or 20 to 25 watts power dissipation in the transformer, which is in line with what I was getting last year in last year's experiments as well. And of course, running these on just straight up mains, 90 watts in a pair of them, so about 45 watts of losses in each transformer. So yeah. Whereas proper continuous duty mains transformers like this one is, by my calculations, dissipating probably on the order of about a watt. With about 64 rated watts of lamps. Again, I haven't independently measured each lamp to see what its power consumption is, but with 64 rated watts of lamps, the system is using about 70 to 72 watts, so that's about 6 to 8 watts of losses in the transformers. Of course, the big one's dissipating probably about 5, slightly more now that it's under load, because there's the I2R losses in the secondary to account as well, and some additional ones in the primary besides those due to the magnetizing current, but usual rubbish. And so yeah, this obviously, when in doubt, or if possible, proper continuous duty mains power transformers are the way to go. And as a bit of an aside, this is the modified board. Put the receptacle in a proper J-box, and I also added a push button switch for the light. Just ease of controlling it, and there's the 8-watt LED. That's a, relatively speaking now in this day and age, new old stock, well, slightly modified, because there was a bit of crap on the die from assembly, so I had to break the lens off to fix that. So, but given that I've replaced the lens with just a piece of sheet plastic, it's a much wider beam, which for my purposes is advantageous. And that's just a General Electric 23-watt cool white Helicrap, and a big clamp light that's just illuminating this patch of woods back here. And as a new addition to this experiment, this is just a bit of an additional feeder line that I put in yesterday, and this light, which kind of a street light-ish thing. It's a 20-watt General Electric daylight Helicrap, 50-watt control transformer, or something like a control transformer. It's estimated probably about 50 volt amperes from the size. And receptacle, yes, it doesn't have a cover plate, but again, this is a provisional test board that I built. And again, given that there's 1,240 volts exposed on that thing, again, just don't touch. Then again, this is experimentation intended for those who know what they're doing, or there seem to. Again, proper safety rubbish. Again, don't attempt at home, risk of electrocution. There's a Helicrap again. That's just a typical junction box mount lamp holder there. And a junction box just stuck on a piece of a 2-inch by 2-inch board with these staples, and the paper toweling is just there to keep the staples from cutting into the wire, because I don't have any cable or can't find my big jar of cable staples, and they aren't designed for wiring this small. But yeah, it's a thing, and it works, knock on wood. And that other wire just going to a little ground rod, just as a bit of a safety thing, just to keep any user accessible potentials from skyrocketing wildly if the neutral gets cut for any reason, although hopefully knock on wood that will never have to work, because this isn't a single wire earth return. There is a the neutral up there is being used as the normal return for the H2 side.